Hello and welcome. I'm Kamal Takodra. I'm a technical marketing engineer in the Aruba Switching Business Unit. In this 10.10 update, I'm going to be talking to you about IPv6 security enhancement, DHCPv6 Guard. Firstly, we will cover a feature overview. Then we'll cover some use cases around DHCPv6 Guard. Cover some details about the feature, then some configuration and troubleshooting around DHCPv6 Guard. Then we'll go across to a demo, and we'll cover some additional resources that are available to you. Overview: DHCPv6 Guard. DHCP snooping for v6 block packets from rogue DHCP servers. DHCP packets received on untrusted ports are immediately dropped. DHCP packets received on trusted ports are forwarded. So platforms supported with 6200, 6300, 6400, 8360 and 8400. DHCPv6 Guard enhancement is an extension of the current DHCPv6 snooping. The extension for DHCPv6 snooping allows filtering of advertised and replay messages using policies to ensure clients receive an address or prefix from authorized servers, effectively to block access with differentiation on a trusted port. Now 10.10 provides for a policy to be applied on a trusted port or a VLAN. So the policy options are access control lists, prefix list, and DHCPv6 preference. Now let's look at a use case. Here we can see that a DHCPv6 offer, both legitimate and fake, are coming over a trusted port. We need to be able to allow the legitimate offer through, but at the same time block the fake DHCP server, providing assignment to the hosts. Now 10.10 provides for a policy to be applied on a trusted port or VLAN. To further differentiate the DHCPv6 on the trusted ports, we use policy options which include a DHCP server preference, an ACL which can recognize the server source and match on that, and also client advertised prefixes. Let's look at some of the details around DHCPv6 Guard. Feature details. DHCPv6 Guard is policy-based, and it must coexist with DHCPv6 snooping. Its applied policy will take effect only if DHCPv6 snooping is enabled globally and under the VLAN context where DHCP packets are received. Policies applied on a VLAN will be effective only for DHCP packets received on the snooping trusted ports, which are part of that particular VLAN. Policies applied on a port is applicable to DHCPv6 Guard trusted ports only. DHCPv6 Guard policy applied to an untrusted port will be ineffective. That means DHCPv6 packets received on this port will be dropped without any type of inspection. Only one policy can be applied per VLAN or interface at a given point in time. DHCPv6 Guard policy cannot be applied to an interface where routing is enabled. Note by default, all ports are deemed untrusted. DHCPv6 preference default value is to allow a range of between 0 and 255. Policies applied on a port will take priority over policies applied on a VLAN. If any parameters in the policy fail, DHCP packets will be dropped. In other words, all parameters in a policy must pass to enable the forwarding of packets. Supported on multi-SASE lags and lag interfaces. DHCPv6 policy is not supported on VXLAN endpoints. DHCPv6 policy can be applied to ISO links on VSX switches, but it's not really required, as DHCPv6 should have been intercepted by the VSX peer itself. Let's go through some configuration and troubleshooting for DHCPv6 Guard. Let's start off with an example VLAN bound policy. The first thing we need to do is enable DHCPv6 snooping globally. The second step is define a policy. You give it a name, and then you look at what you want to apply to that policy. Here we've based on server preference flag. The next step is step 3, is define a trusted port for forwarding or dropping of DHCPv6 packets based on the policy. Last and final step is enable DHCPv6 snooping on the VLAN and then add the policy that we created from step 2. Next, let's look at an example port-bound policy with an access control list. I'm modifying the previous configuration and permitting server with an ACL and overriding the existing VLAN policy. So the first thing is I define it ACL. Here our trusted source is just a linked local address actually. The second step is to create a policy referencing the ACL I created earlier. Step 3 is to add a policy that we created to the actual trusted port in this instance. And just for reference, the VLAN policy is now ignored as port policy takes preference. In this example, we have a port-bound policy which is multi-dimensional with ACLs and preference. Here we take the previous configuration. We have multiple rules in the policy. Please note, all rules must pass to forward the packet. And in this policy, we've simply taken the previous policy, which had the ACL, and added a server preference, here between 50 and 70. Here is a list of show commands and statistic commands and debugs that can be used in assisting troubleshooting DHCPv6 Guard. Here, in the next output, you can see we can use the show DHCPv6 snooping statistics to see both server and client forwarded packets. Let's look at an example of how policy is constructed and where it's applied. We can issue a show DHCPv6 snooping guard policy, and we see immediately we have two policies defined. We have a port policy with an ACL with a default server preference of between 0 and 255. Lower down we also see we have a VLAN policy with a server preference between 50 and 70. Let's look at some example policy statistics. We issue a show DHCPv6 snooping guard policy with the VLAN context. We can see the policy name. We can see the policy counters. Here we received 12 and dropped 12 packets. We can also see there are 3 possible reasons for a drop, and the counters are logged here. Finally, we do see a reason for a drop. The preference is out of policy in this case. Here we look at an example debug policy. Here DHCPv6 is dropped as it is out of policy due to the ACL that we have issued, and we have a mismatch with the policy. Now for a demo around DHCPv6 Guard. Let's briefly go over the demo setup. We have a 6300 switch as a device under test, and we have a client, Windows client, on port 1110. We have a DHCP server on port 115, and we have a trust applied to port 115. The server is configured with a preference of 99, and we have a v6 address of 201 db8 1969 1234 : 201. We also have a link local address for the server, and then we have DHCP scope of 201 db8 1969 1234 : 10 up to 20. So just as a reminder, this is the test topology I have for this feature. I have a Windows 10 client connected to port 1110 of my 6300. The client is looking for a v6 assignment and it's connected to VLAN 1969. I have a DHCP server connected to port 115 of the same switch in the same VLAN. I have a trust configured on this port of the 6300 for v6 snooping. This server is configured with a preference of 99. I have a link local address as shown here, and I also have a effectively a privately routable address as well. I've also got a scope on here of 201 db8 1969 1234 : 10 up to 20. So this will be a assignment to the client from this scope, from this server to here. And what we'll do is we'll change this, obviously it's a trust, but we'll be putting the policy on the VLAN and on the port, both allow and deny. So first of all, let's go and have a look at the configuration. It's relatively basic at the moment. You can see I've got DHCP snooping configured globally. I've already got DHCPv6 snooping configured on the VLAN in question, and then on port 115 I have DHCP v6 snooping trust, and then on port 1110, so trust, this is where the server is connected, and then on port 1110 I've just got an access VLAN in VLAN 1969. So that's the basic configuration. So let's go across to the client and get a DHCP v6 address first. So I'm on this client here. I'm going to release the addresses first. Release 6. So I have no v6 automatic assignment effectively. And then I just do a renew. it should give me a v6 address on my client, and there you are with that scope. You can see it's got the 2001 DB8 1969 1234 : 20. So if I just go across to my switch, I can just check that out by looking at my DHCPv6 snooping statistics to see that we've had some hits. Sorry, to show DHCPv6 snooping statistics. So we can see from these counters that we've had some activity from DHCP between the server and client, and we've recorded these hits on these counters. So the next thing is let's apply a policy onto the VLAN. So if I just do a show run, I've already started off a policy right at the bottom. So I've created a DHCP snooping guard policy called my preference. So let's add to this policy, and if I just hit the question mark, it gives me the options, and I'm just going to have a preference. I'm going to look for a specific preference. I remember the preference of our DHCP server is 99, so I'm going to block this. So if I configure a preference lower than 99, we should block it. So let's put a preference of 70. I think it's a maximum. Yes, I took a maximum of 70. You can also put a minimum preference in as well. So let's put an arbitrary minimum in. So I will say 50. If I do a show run current context, we'll now see that I've got a minimum of 50 and a maximum 70. That means that our DHCP server will not be within that range because it's actually has a value of 99 when it sends its offer effectively. So we now need to apply that to the VLAN. So I go to VLAN 1969 and I take that policy, and I just have to say DHCPv6 snooping. I think it's guard policy, and then name the policy, which I'd already just take a cut and paste of that, and that's it. Now that's that policy applied to the VLAN. So let's just take a quick look, see if we can see some statistics on that actual policy itself. So we just do a show DHCPv6 snooping policy, guard policy, and then the VLAN that is applied to. Currently we see well, it's already, we've got some dropped packets because we've applied the policy. There's obviously some activity going here in the background. So if I do a release, do a release and a renew, we'll see that so I've lost the address now, so there's no v6 address like there was before with this 20 at the end, and I'm going to do a renew. Six, and it should just effectively hang, and you can see it's hanging. It's not really getting an address. Now it's being blocked. If I go back to my statistics, we can see now, as I've repeated it, I've had a further 10 packets dropped, and the reason they've been dropped is because I've had an error, or effectively because of the server preference. So that just shows you how we're blocking based on preference on the VLAN. So now let's look at applying a port policy. And what we're going to do is we currently have blocked a assignment to this client because of the preference. We're going to apply now a policy to the port to override that VLAN policy. You don't need a VLAN policy, but just to show you the effectiveness of the port policy takes priority over the VLAN policy, will allow the server's address here, this link local address, and therefore it will override the policy with a permit, and this will be negated on the VLAN policy effectively. So let's go across and configure the port policy. So let's have a look at the configuration. I've already created a policy here, DHCP snooping guard policy. I've called it my DHCPv6 pol p. It's empty. So let's apply the policy. Let's apply an access list to this policy. So if I go conf t for, I've also defined a access list already. So if I do a show access lists, I've got a single access list allowing a permit on this link local address, which is the address, link local address of this DHCPv6 server. So we just need to go into this policy that I defined earlier, and then we do a match, and we say it's the server, and we say access list, and we reference the access list name, which is this access list, and that should be, yeah, and that's it. Okay, now I have to apply this policy onto the interface. So we go interface /1/5, which we have the show current server config. So let's have a look at the current context. We've got nothing on there apart from a trust. So let's apply this policy. So I simply type in DHCPv6 snooping guard policy, and then the name of the policy, which is here. There we are. That is now applied. So let's go across and see with that policy applied. As we can see, we had an error earlier of the v6 client not getting an address. So let's go in and try and renew this v6 address. Let's try it straight off the bat, and there we are. Straight away I've got this v6 address on my client, and let's just have a look at some of the statistics so we can quickly look at the DHCP snooping statistics for this specific policy on an interface, just to see that we've got it. So it's just a show DHCPv6 snooping guard policy, and put the interface, which is 1/1/5. Oops, put in interface 1/1/5. We should get some statistics. So we can see that we've had the 5 packets received and forwarded. We've got no errors here. So effectively it passed the rules and allowed an IPv6 assignment to pass. So what we're going to do now is we're going to add to the port policy and make a block again, and then have a look at some debugs. So if we quickly just remind ourselves of the config, here we are. So if I actually exit this and then go back into the policy, and then we'll block it also based on preference. So we've got the server match already, so let's add a preference to, and let's make that preference a maximum of 70. Now that policy has now immediately been applied. Now if we try an assignment, we will see a block occur of the assignment. So let's go back to our Windows server. Let's do a release first. So we've released it. Let's try a renew. Should fail. We can see that it's hanging. So while it's hanging, let's have a quick look at the policy statistics. We just have a quick interface. That didn't work. Show interface 1/1/5. Okay, now you can see, even though my policy had allowed the server IP address, we've now further blocked it on the actual preference, because the preference of the server is 99. Just shows that how you can manipulate the policy. So all parts of the policy must pass to be able to allow the actual assignment of the IP address. Now we can look at that in the debug as well. So let me just clear the debug buffer first so we can see that immediately, and then I just do a debug buffer, sorry, debug DHCPv6 snooping v6 snooping without a space, and I'll put a debug all, and then simply we can do a show debug buffer include DHCPv6, and we should be able to now spot the actual block. Show include DHCPv6. Okay, so let's have a quick look at these debug messages. Let's open this up a bit so we have a better view. Let's run that again. Okay, that looks better. So let's have a look what's happening here. So let's see. We see Cray 1969 packet received, packet server. Okay, here we go. So we received a packet on port 115, and later on we see the packet server preference 99 is not in the range of policy, and therefore the packet is rejected on that policy that applied to the port. Okay, well, hopefully that was useful to you and provided a summary of this feature, DHCPv6 Guard. Thank you for watching. Let's cover a few resources for DHCPv6 Guard. The following RFCs 7610, 7113, 4861 are quite useful to understand DHCPv6. Also, I'd highly recommend looking at our YouTube ABC networking channel and search for IPv6. There's a lot of content around that too there. Thank you for taking the time to watch this information on DHCPv6 feature for 10.10. I hope this is informative and useful for you.